The minimum service panel distances in a commercial site are crucial for safety, accessibility, and compliance with electrical codes. Firstly, considering the distance from the floor, the minimum height for the top of the service panel is typically 6 feet or 1.83 meters. This height ensures that the panel is easily accessible for electricians and other qualified personnel to operate and maintain without undue strain. Secondly, regarding the distance from the ceiling, a minimum clearance of 18 inches or 457 millimeters is required above the service panel. This space is essential for adequate ventilation and heat dissipation, preventing overheating and potential fire hazards within the panel. Thirdly, addressing the distance from doors or windows, a minimum clearance of 3 feet or 0.91 meters is necessary. This spacing prevents obstructions that could hinder access to the panel during emergencies or maintenance procedures. This distance also reduces the risk of accidental contact with live electrical components. Fourthly, when considering the distance from other obstructions, a minimum of 3 feet or 0.91 meters is generally required. This clearance ensures that the service panel remains readily accessible and that electricians have enough space to work safely without encountering obstacles. Additional considerations are also important for the proper installation and maintenance of service panels. Higher boards should be readily accessible without the use of a ladder or other means. This accessibility ensures that personnel can quickly and safely respond to any electrical issues or perform routine maintenance tasks. Panel boards should be located in a dry and ventilated area. Moisture and poor ventilation can lead to corrosion, short circuits, and other electrical problems. A dry and well-ventilated environment helps to maintain the panel's integrity and prolong its lifespan. Panel boards should be protected from physical damage and tampering. Protective measures such as enclosures or barriers can prevent accidental damage from equipment or unauthorized access to the panel's internal components. Clear working space should be provided in front of the panel board for servicing and maintenance. Sufficient space allows electricians to perform their work safely and efficiently, reducing the risk of accidents or injuries. Clear working space typically involves a minimum depth and width that complies with the National Electrical Code, or NEC, requirements. The NEC is a comprehensive set of standards that outlines the safe installation of electrical wiring and equipment. It is widely adopted in the United States and serves as a benchmark for electrical safety in many other countries. The NEC provides specific guidelines for working clearances around electrical equipment, including service panels. These clearances are designed to protect electricians and other personnel from electrical shock and arc flash hazards. Working clearance includes the depth of the space, which is the distance from the front of the equipment to any opposing surface, and the width of the space, which is the horizontal distance available for movement. The required depth of the working space depends on the voltage of the equipment and the presence of any exposed live parts. For example, for equipment operating at 150 volts to ground or less, the NEC typically requires a minimum depth of 3 feet or 0.91 meters. For equipment operating at higher voltages, the required depth increases accordingly. The width of the working space should be at least 30 inches or 762 millimeters wide, or the width of the equipment, whichever is greater. This width allows electricians to move freely and perform their work without being cramped or restricted. The height of the working space should be at least 6 feet 6 inches or 1.98 meters, or the height of the equipment, whichever is greater. This height ensures that electricians have enough headroom to work comfortably and safely. In addition to working clearances, the NEC also specifies requirements for the location of service panels. Service panels should be located in readily accessible locations that are free from obstructions. They should not be installed in hazardous locations, such as areas where flammable materials are stored. Service panels should also be protected from physical damage, such as impact from vehicles or equipment. The NEC also addresses the proper grounding and bonding of service panels. Grounding and bonding are essential for preventing electrical shock hazards and ensuring the safe operation of electrical equipment. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current. The NEC specifies the size and type of grounding and bonding conductors that are required for service panels. It also requires that all grounding and bonding connections be made securely and effectively. Proper labeling of service panels is also important for safety and convenience. Each circuit breaker or fuse should be clearly labeled to indicate the equipment or area that it serves. This labeling helps electricians and other personnel quickly identify the correct circuit breaker or fuse to de-energize when performing maintenance or troubleshooting. The NEC also requires that service panels be inspected and maintained regularly. Regular inspections can help identify potential problems before they become serious hazards. Maintenance tasks such as tightening connections and cleaning components can help to ensure the safe and reliable operation of the service panel. In addition to the NEC, local codes and regulations may also impose additional requirements for service panel installations. It is important to consult with a qualified electrician and local building officials to ensure compliance with all applicable codes and regulations. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician for specific guidance on service panel installations. In summary, the minimum service panel distances in a commercial site are crucial for safety, accessibility, and compliance with electrical codes. These distances include the height from the floor, clearance from the ceiling, distance from doors and windows, and clearance from other obstructions. Additional considerations include ensuring ready accessibility, locating the panel in a dry and ventilated area, protecting it from physical damage and tampering, and providing clear working space. Compliance with the NEC and local codes and regulations is essential for ensuring the safe and reliable operation of service panels in commercial settings. Consulting with a qualified electrician is always recommended for specific guidance on service panel installations. The National Electrical Code provides tables that specify the minimum working clearances required around electrical equipment. These tables are based on the voltage of the equipment and the presence of any exposed live parts. For example, NEC Table 110.26. A1 provides the minimum depth of working space in front of electrical equipment operating at various voltages. The required depth ranges from 3 feet or 0.91 meters to 4 feet or 1.22 meters, depending on the voltage and the presence of exposed live parts on both sides of the working space. The NEC also specifies the minimum width of the working space, which should be at least 30 inches or 762 millimeters, or the width of the equipment, whichever is greater. The height of the working space should be at least 6 feet 6 inches or 1.98 meters, or the height of the equipment, whichever is greater. In addition to working clearances, the NEC also addresses the proper installation of service panels. Service panels should be securely mounted to a wall or other support structure. They should be located in readily accessible locations that are free from obstructions. Service panels should not be installed in damp or wet locations unless they are specifically designed for such environments. The NEC also specifies the requirements for grounding and bonding of service panels. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current. The NEC requires that all service panels be grounded to a grounding electrode system, which typically consists of one or more ground rods or a metal water pipe. The grounding electrode system should be connected to the service panel with a grounding electrode conductor, which should be sized according to NEC Table 250.66. The NEC also requires that all metal enclosures of electrical equipment, including service panels, be bonded together with bonding jumpers. Bonding jumpers should be sized according to NEC Table 250.102. Seat 1. Proper labeling of service panels is also important for safety and convenience. Each circuit breaker or fuse should be clearly labeled to indicate the equipment or area that it serves. The labeling should be legible and durable, and it should be updated whenever changes are made to the electrical system. The NEC also requires that service panels be inspected and maintained regularly. Regular inspections can help identify potential problems before they become serious hazards. Maintenance tasks, such as tightening connections and cleaning components, can help to ensure the safe and reliable operation of the service panel. The frequency of inspections and maintenance should be determined based on the operating environment and the type of equipment. In addition to the NEC, local codes and regulations may also impose additional requirements for service panel installations. It is important to consult with a qualified electrician and local building officials to ensure compliance with all applicable codes and regulations. These distances are minimum requirements and may vary depending on local codes and regulations. It is recommended to consult with a qualified electrician for specific guidance. This consultation ensures that the electrical system meets all applicable safety standards and is suitable for the specific application. The role of a qualified electrician is to assess the electrical needs of the commercial site, design the electrical system to meet those needs, and install the system in accordance with all applicable codes and regulations. The electrician will also ensure that the service panel is properly sized to handle the expected load and that it is installed in a location that is readily accessible for maintenance and repairs. Furthermore, a qualified electrician can provide guidance on energy efficiency measures and help to reduce energy consumption. This guidance can include recommendations on energy-efficient lighting appliances and other electrical equipment. The electrician can also help to identify and correct any existing electrical problems that may be wasting energy. In addition to the installation of new electrical systems, a qualified electrician can also provide maintenance and repair services for existing systems. Regular maintenance can help to prevent electrical problems from developing and can extend the life of the electrical system. Repair services can address any electrical problems that may arise, such as power outages, circuit breaker trips, and faulty wiring. When selecting a qualified electrician, it is important to choose someone who is licensed and insured. A licensed electrician has met the requirements of the local licensing board and has demonstrated competence in electrical work. Insurance protects the property owner from liability in case of accidents or injuries that may occur during the electrical work. It is also a good idea to check references and read reviews before hiring an electrician. This checking can help to ensure that the electrician is reputable and provides quality service. Overall, adhering to the minimum service panel distances and consulting with a qualified electrician are essential for ensuring the safety and reliability of electrical systems in commercial sites. These measures help to protect people and property from electrical hazards and ensure that the electrical system meets all applicable codes and regulations. It's important to also consider the wire bending space at terminals within the service panel. The NEC dictates the minimum wire bending space based on the conductor size and the type of connector used. Adequate wire bending space allows for proper installation and termination of conductors, reducing stress on the connections and preventing potential failures. Always refer to the NEC tables for specific requirements. Proper grounding and bonding are crucial for safety. Grounding provides a path for fault current to flow back to the source, tripping a breaker or fuse and energizing the circuit. Bonding ensures that all metallic parts of the electrical system are at the same potential, minimizing the risk of electric shock. The grounding electrode system must be properly installed and maintained according to NEC standards. Remember to consider the ambient temperature when selecting conductors and determining their ampacity. The ampacity of a conductor is its current carrying capacity. High ambient temperatures can reduce the ampacity of conductors, so it's important to make adjustments accordingly. The NEC provides tables and guidelines for ampacity dating based on ambient temperature. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The size of the overcurrent protection device must be properly matched to the ampacity of the conductors it protects. Using an undersized overcurrent protection device can result in nuisance tripping, while using an oversized device can allow the conductors to overheat and potentially cause a fire. Always refer to the NEC for proper overcurrent protection requirements. Arc flash is a dangerous electrical hazard that can occur when a fault current flows through the air. Arc flash can generate intense heat and pressure, causing severe burns, injuries, and even death. It's important to take precautions to minimize the risk of arc flash, such as wearing appropriate personal protective equipment, or PPE, and following safe work practices. An arc flash risk assessment should be performed to determine the potential hazards and to select the appropriate PPE. Regular electrical inspections are essential for identifying potential problems and ensuring the safe and reliable operation of electrical systems. Inspections should be performed by qualified personnel who are familiar with the NEC and other applicable codes and standards. Inspection findings should be documented and addressed promptly. Proper maintenance of electrical equipment is also important. Maintenance tasks can include cleaning, tightening connections, lubricating moving parts, and replacing worn components. A preventative maintenance program can help to extend the life of electrical equipment and prevent unexpected failures. Always de-energize electrical equipment before performing any maintenance. Lockout/tagout procedures should be followed to ensure that the equipment remains de-energized during maintenance. Lockout/tagout involves disconnecting the power source and placing a lock and tag on the disconnect switch to prevent accidental re-energization. Electrical safety training is essential for all personnel who work with or around electrical equipment. Training should cover topics such as electrical hazards, safe work practices, PPE, and lockout/tagout procedures. Regular refresher training should be provided to ensure that personnel stay up to date on the latest safety practices. When working with electrical equipment, always use insulated tools and equipment. Insulated tools and equipment provide a barrier between the worker and the electrical current, reducing the risk of electric shock. Inspect insulated tools and equipment regularly for damage and replace them if necessary. Never work on electrical equipment while wet or standing in water. Water is a good conductor of electricity, and it can significantly increase the risk of electric shock. If you must work in a wet environment, use appropriate waterproof clothing and equipment. Report any electrical hazards or unsafe conditions to your supervisor or to the appropriate authorities. Prompt reporting can help to prevent accidents and injuries. Follow all applicable safety codes and regulations when working with electrical equipment. Safety codes and regulations are designed to protect workers and the public from electrical hazards. Failure to follow these codes and regulations can result in fines, penalties, and even criminal charges. Stay informed about the latest electrical safety standards and practices. The electrical industry is constantly evolving, and new safety standards and practices are being developed all the time. Staying informed can help you to stay safe and prevent accidents. Always prioritize safety when working with electrical equipment. Electrical work can be dangerous, but by following safe work practices and using appropriate safety equipment, you can significantly reduce the risk of accidents and injuries. Furthermore, consider the accessibility requirements outlined in the Americans with Disabilities Act, or ADA, when planning the location of service panels. The ADA requires that electrical equipment be accessible to individuals with disabilities. This accessibility may include providing clear maneuvering space around the panel and ensuring that the controls are within reach. Also remember to consider the environmental conditions when selecting and installing service panels. If the panel is located in a corrosive environment, such as a coastal area or an industrial facility, it should be constructed of corrosion-resistant materials. The panel should also be properly sealed to prevent moisture and contaminants from entering. When installing a service panel, ensure that it is properly aligned and plumb. A misaligned panel can put stress on the wiring connections and can make it difficult to close the panel door. Use a level to ensure that the panel is plumb before tightening the mounting screws. After the service panel is installed, test all of the circuit breakers and fuses to ensure that they are functioning properly. Use a circuit tester to verify that each circuit is properly energized. Label each circuit breaker and fuse clearly and accurately. The labeling should indicate the equipment or area that is served by the circuit. Keep a copy of the panel schedule in a convenient location, such as inside the panel door. A detailed panel schedule can be invaluable for troubleshooting electrical problems. The information provided here is for general guidance only and should not be considered a substitute for professional advice.